everyone has a clear view of the webinar. We're going to be talking about automated support removal for PolyJet. So today's agenda is going to look like this. I am Andy Cottage. I'm from PostProcess. Today we're going to be talking about who is PostProcess for a moment, and then we're going to get into the meat of the content, which is the support removal process, some of the challenges you might be facing today if you're a PolyJet user, and then a solution for soluble support removal that PostProcess can offer to maybe alleviate some of those challenges that you're facing. Then we'll talk about a case study, and ultimately I want this to be an active session. If you feel like you have a question that pops up throughout the session here today, feel free to chime in, whether it's via chat. We'll definitely leave questions at the end if you feel like that works better for you. But either way, we are here today to talk about PolyJet support removal, and hopefully we start answering some of those questions that you have for your post-print process. As I mentioned, just a little bit about who PostProcess is. PostProcess is focused strictly on the third step of the additive manufacturing workflow, which is the post-print step. You have design, you print, and of course you have to do something with that print in most cases. A lot of times it's what you see over here. It's support removal, which we're going to be diving in deeper today, but we also address resin removal, powder removal, and surface finishing, really for all 3D print technologies. So our goal is, as I mentioned, a focus on additive manufacturing, specifically that post-print step. But we do take a comprehensive approach. We look at those design and build phases and understand that they all have an impact on one another, and all that data is really meaningful. And that's really the core of who we are, is leveraging that data and software to really build a cohesive and comprehensive process. And then solutions that we offer really allow users to scale additive manufacturing, to scale that print technology that they've invested in to a level that allows them to either reach production levels, minimize some of the challenges that we're going to dive into, and really just fully unleash the capability of additive manufacturing. So when we start talking specifically about PolyJet, we just want to align on the problem, and hopefully for you PolyJet users, this is hopefully painfully obvious. Manual labor and traditional manufacturings are often used. As you see some of the images here, it can be just very old school picks and brushes, things that are lying around the facility, a lot of scraping, picking at different geometries, and trying to knock off some of that support material very manually. Or you could be potentially working with some traditional manufacturing systems. One that we most commonly see is a water blaster or water jetting. And this is the system where you stick your hands in, you have a higher pressure hose, and you're really just trying to knock away support material. And that can be challenging. We'll talk about what those challenges look like in a moment. And then potentially for some of the soluble supports like 706, you could be dealing with some traditional tanks where you're essentially just submerging parts and they're soaking, and they're never really designed for additive, and you run into some additional challenges there. So what does this ultimately mean? You run into time-consuming processes. Your throughput could be low. You might hit a real strong bottleneck when you get to post-printing. You're printing 30, 40, 50 parts a day maybe, and you really can't post-print them. So you find yourself limited once they get off the printer. And you don't have to be printing 30, 40, 50 to reach that amount, or to reach that bottleneck, especially in PolyJet. Either way, you might be struggling with low throughput. Then inconsistency, that can be especially challenging with these manual processes. And then if you're thinking in terms of ROI, am I actually getting a payback on my post-print investment? Might not be. So, and if you are, it might take a very long time to realize the benefits of that investment. So if we break these down just a little bit more, the traditional manufacturing, so if we think about water jetting, something that, again, that was never really designed for additive per se, and even some that are geared towards additive, you know, they have certain limitations. So some of those limitations might be long and unpredictable cycle times. You have different users that try to use these equipment. User A might not give you the same results as user B, and that can be challenging. It's almost a little bit of a skill that has to develop there. And that can be hard to scale and get the right people in the door that can do that process time and time again. Then you get into manual controls. So some of these manual controls, again, can be very challenging to have some of those predictable cycle times or that consistency. But some of those other issues are just, you have to be hands-on with the machine. So you can't really step away and do other value-added work. You're stuck in front of that machine doing one at a time. And then you could also run into other issues, whether it's ergonomic issues, it's not very comfortable working environment to be operating specifically here a water jet machine. And then again, it was never really designed for additive. You know, it's not specific to additive, which just allows itself to a bunch of opportunity. You know, what considerations were overlooked in developing that solution to be able to post print. Then of course, significant labor. You know, if you want to scale, it's really a matter of adding more machines and adding more people to operate those machines. And we know that that can be a huge challenge, especially when you have an automated print solution that's, you don't require someone to stand in front of a printer to print parts. So the fact that you might have to post print them, things become a bit lopsided, and again, you run into that bottleneck. So speaking of manual labor, with the picks and the brushes, one of the biggest things we see in PolyJet is higher breakage. When you're this hands-on with one part at a time, a lot of these people, no one's really trained in post printing. You just kind of learn as you go. You make mistakes as you go, and unfortunately, you break things as you go. And with some of these other materials that PolyJet has to offer, they can be a bit more fragile, especially when you get into some unique geometries and more flexible materials like your ADDITIVE, and maybe some are still using Tango. Things are tearing, so you can just, it's easy to break parts with PolyJet. It can be, depending on your geometry. We talked about inconsistency, and hopefully that one is glaringly obvious, is that you just, if you do want to scale up, ideally you're going to want to have parts that all look the same at the end of the day, and that can be extremely challenging if you're doing one at a time. Again, it becomes this skill or sort of this craftsmanship that's really hard to scale and grow over time. And then again, we mentioned this one too, and it applies, of course, to picks and brushes, or whatever tools you might be using out there, dental picks, those sorts of things. If that's the really what you're relying on for post printing, it's going to be extremely time consuming for the operator. It's not a job that many people are going to want to do over time for an extended period of time, day in and day out. It can just be very challenging. Especially as you have new parts coming off the printer every day. If you're a service bureau, or if you're just iterating constantly, each time you see a part, it's a brand new challenge. It's a brand new consideration when they're post printing. So each time you just are constantly presenting a new challenge, which again increases the risk of everything that we've talked about. And just want to touch on here, we do have an annual additive post-printing survey, and it's across the board, the challenges from post-printing. It's not just PolyJet that's having this problem. It's support removal, resin removal, powder removal, all core print technologies that are communicating that post-printing, regardless of your next step, whether it's coating, dyeing, drying, just to get it to that next step, surface finishing, removing that support is a challenge for over half of the users in these core print technologies. So it's something that a lot of people are trying a problem that a lot of users are trying to solve, and a lot of people are also starting to have success. And one little story we wanted to share here was Johns Hopkins, who's of course a name you probably recognize, and they're in the medical space. So you can see some of the challenging geometries that they've had, and Some of these geometries might look familiar to some of you, some of these organic shapes that the medical industry is creating for just medical models, simulations for maybe surgeries and so forth, these anatomical models. And essentially what summarizes Johns Hopkins' success is really just decreasing the overall cycle time and improve the consistency. So you can imagine trying to clean this part completely by hand. It can be extremely challenging, and when you look at this after photo, you can imagine it's very easy to potentially damage a part like that. So this is a Senti unit, which is a compact tabletop unit, but the success would apply to some of our larger units as well. It's a similar technology, but Johns Hopkins benefited from a tabletop unit. A little bit lower throughput, but still running into a lot of the same challenges. So they decided they didn't want an operator or to just be stuck in front of these parts for hours at a time. And they benefited from the Senti's technology. So that's a segue really into our solution. Each one of our solutions, we really pride ourselves on 3 legs. It's the software, hardware, and chemistry. And as I alluded to at the top, software really being the foundation of it. It's really going to be the brains behind our process. But of course, you need the hardware and chemistry to work with that software. And that's where we have our teams here at PostProcess working on really that comprehensive approach, making sure that the software is taking full advantage of the hardware capabilities and what the chemistry needs to be optimized. So that's really the way we approach each one of our problem is to take those 3 legs and attack that problem, making sure that there's a synergy that happens there to create the optimized solution. But ultimately, when we look at PolyJet and what we're calling here just the solution summary, we're going to dive into each one of these a little bit. The higher throughput, we're going to talk about advanced process control, and that really leading to minimize operating errors. I just want to touch on the value of additive manufacturing expertise as well. And then we mentioned the ROI portion of all of this. So we'll touch on an example here at the end as well. So when you think about higher throughput, really just trying to get more parts through your workflow, being able to process in batches, eliminate a lot of that hands-on time. Really, we did a white paper on this that's available if you're looking to dive a little bit deeper, but it talks about that increased throughput by over 30% in this instance compared to traditional water blasting. So we touched on some of the issues with traditional water blasting with the manual controls and all the labor that goes into it. In this study, we focused on the DEMI, which is from our SVC technology line, and again, increasing the throughput by 30% compared to some traditional systems. So if you're looking to ramp up and scale your operation, again, without not adding a bunch of additional manual labor, additional water blasting equipment, this is something that may interest you, the SVC solution, with the automated software, which is really going to take a lot of that manual labor and allow you to scale. Then we talk about advanced process control. So what does that mean to the user? Really, ultimately, we're leveraging software to be able to optimize our hardware more effectively. So we can, for instance, our ultrasonics and our SVC technology, they're not just on or off. We can change the power that the ultrasonics are putting out. Things like, basically the way we are introducing agitation into the system through our flow. So the way we're distributing temperature and really that physical agitation to the part, all controlled through our software. Really provides flexibility for more difficult geometries, ultimately lowering labor costs in a lot of instances. And again, that breakage piece that's really important in PolyJet, minimizing or eliminating that, and really just getting that consistency. So with that software, it's really press and play. You can have settings saved where essentially you're dropping in a part and literally pressing a play button and getting that expected result each and every time. So But that is a big piece, minimizing that warpage and breakage through that advanced process control, not getting into situations where your temperature is running wild, or it's hitting maybe a pump flow in a certain way that's too aggressive and breaking parts. So again, that advanced process control really providing the benefits listed over here on the right-hand side. And ultimately, with all that manual labor, really just human error becomes a factor. There's only so much you can expect if someone's repeating the jobs day in, day out. Fatigue plays a role. So really what we try to do is, if someone's going from, a hands-on operation like that to a software-driven solution, we understand that they don't want to be programmers. They don't want to have to, write code and figure out all of the nuances of the solution. So what we try to do is really to simplify it. We have really 3 key settings in our solution: agitation level, temperature, and time, that really allows the user to simplify that process. And then we're monitoring the process real time. So we understand if the temperature is starting to increase and how to be proactive about maintaining that. We understand if your filters are starting to get a little clogged up. So there's things that we're monitoring throughout the whole process. If your tank level is getting low, we'll make sure that you stay aware of what's going on in your process so you can maintain that consistency, and you don't have to stand in front of the machine and worry about if it's operating within the boundaries that you've set. Same thing, after the cycle, any proactive or preventative maintenance warnings, letting you know if there's any steps you should take to maintain your machine. And then the simple fact that, we can remove really each one of the support materials that PolyJet offers in one solution, and really simultaneously. We use the same detergent for all PolyJet applications. So it really just allows a user to simplify the whole thought process there. It's going to be going through one solution. So you don't have to worry about if it's 705 or 706. Do I water blast? Do I soak? It all can go in the same solution. And I touched on it earlier on this slide, the 1-button recipe selection for repeatability. So being able to just have those save settings again, so that way each time you run the process, you're getting the same results. Then the additive manufacturing expertise. Really, the main thing that I want to communicate here is that this is our sole focus. We don't design printers. We focus strictly on the post-print side while working closely with the upstream processes. But this is where our energy goes, both from a hardware, software, and chemistry perspective. So that's not only through the really application, understanding your application part, but really the integration and service of the solution, really just making sure that these solutions are aligned to your needs and you taking advantage of our experience, because we're really at the end of the funnel here. We see a lot of different applications. We see a lot of different print technologies. We see emerging print technologies. So being able to share that with you all can be very powerful to make sure that you're getting your most out of your solution. Really bring the most intelligent people in the industry really to your service, to be able to get you all the answers that you need, whether you're trying to introduce new materials, whether you have complicated geometries. You might even be wondering how to print something a little bit differently to post-print more effectively. This is where we can support you. So a little bit about a success story here. This is a multinational technology company that leveraged the DEMI support removal solution. Something we're seeing more often is this internal hub for prototyping, sort of this center of excellence, a lot of people are calling them, printing 50 or more PolyJet parts per day. So they were water jetting and they had some baths. They were only spending 8 minutes of technician time. And at first glance, you might think, hey, that's not a ton per part. 8 minutes seems reasonable. But they did have a very high labor rate. I think they might even had engineers doing the work, which is maybe a surprise to you, but we see that quite often, as a lot of people don't plan for their post-printing. So engineers might get hands-on. So it's an expensive hourly rate. In any case, doing 50 parts a day at 8 minutes, you start doing the math, that can add up quite a bit, even though 8 minutes by itself doesn't seem like a lot. But then all of a sudden you look at the numbers here, where we start to understand what you're currently doing, start to run some benchmarks and understand our capabilities and what we can offer. And in this particular instance, you see a summary down below. It still took 7 hours. So actually this particular customer did not see a throughput increase, but they were able to free up all that manual labor to do more value-added activities. Those engineers could go back to their desk and continue to design or do whatever they do to continue to move things forward, because they went from 8 minutes per part, and now that, you know, they're no longer doing one part at a time. They went to 6 seconds per part, and all of a sudden you look at the total post-print cost, and you go from, you know, $7.50 to just over 30 cents. So in that particular instance, they saw a 20-week ROI. So very powerful. So that's why we like laying out the numbers and truly understanding your process, because there might be some things that are easy to overlook, but once you uncover them, there might be a big opportunity there. Just a little note here. I know we're coming to the end, and I want to leave some opportunity for questions. Again, our ROI process, really understanding your current post-print cost and having you know, the Fisher Unitech team work with you on that, and really understand your process, understand, you know, is there a solution available that could benefit you? And then how do the numbers shake out? How can we make sure that whatever you're investing is actually really going to pay for itself and really increase productivity for you and your team? Another note I'll make here is, you know, we've had success removing all PolyJet support materials. As this list grows, you know, we'll keep an updated list, but I imagine most people here fall in one of these categories. But this is something we keep a close eye on, as I mentioned earlier. Any developing materials, really wanted to stay abreast and make sure that our chemistry is still satisfying our customers' needs. So to wrap it up, really the benefits that we're talking about here are consistency, throughput, and productivity. You know, with that software control process, you can increase your throughput in many instances. And the biggest piece here is reducing that operator time, which is a huge piece of what we just talked about in that success story I mentioned a slide ago. So that's really a takeaway that I want you to have, is that consistency, especially with WaterJet, opportunity to increase your throughput. Maybe you're not spending 8 minutes per part, maybe you're spending 20 or 30 with some complicated geometries. That's very possible. And then that productivity. How can you reduce that manual labor so that ultimately you can go on to more value-added activities and really get a very nice ROI for your investment? So that wraps it up for me today. Of course, we'll leave it open for questions, but if you want to get in contact with us, you have the information up here to email marketing@Fisher Unitech, take a deeper dive. You know, a big part of our process is just understanding you. We do have benchmarking that we provide that really gives you the full details. If we were to try to process any parts for you, really let you know what we did, what was involved, give you the full scope, so you can truly understand what another opportunity out there for you might look like.